Hi, in this session we are going to learn another HackerRank problem called a service lane. So first let's read the question. The first sentence says that Calvin is driving his favorite vehicle on the 101 freeway. Don't worry about what type of vehicle, don't even worry about what is this 101, it's just the name of an highway. He notices that the check engine light of his vehicle is on and he wants to service it immediately to avoid any risk, right? It basically says that there's some problem in his vehicle and he wants to service it, right? And luckily a service lane runs parallel to the highway. There's a service line running parallel, right? But the service line is not of the same width throughout, right? It varies in width along its length. Like you can just say, observe here, this is my service lane and this is the main highway. So at some places a small width out here, somewhere it is quite large, and again there is a smaller one, right? So this is your highway and your service lane, right? So this is the initial part of the problem. Now let us see what we need to do in this particular task. You will be given an array of widths at points along the roads, then the list of indices of entry and exit points. Considering each entry and exit point pair, calculate the maximum size vehicle that can travel that segment of the service road. It basically says that they will be giving you a set of the width of all this section. Let us say this section 1, section 2, right, section 3, section 4. So they will give you the width of every section, right? And then they'll also be providing you the entry point and the exit point. And you need to identify what type of vehicles might enter as well as exit from this service lane from the given entry point and the exit point, right? Okay. Now they are also telling some example, like there are n equal to 4 measurements yielding width, meaning there are 4 sections here, 1, 2, 3, 4, right? And then they're saying that the first one has a width 2, 3, 2, 1. And then if we have to enter from index 1 and then exit from index 2, that is we enter from this section, right, and then we come out after section 2. So in these two sections, two sections, the width is 3 and the width is 2, right? Okay, the kind of vehicles which can enter is, we can make vehicle of width 1 enter into this, we can also make the vehicle width 2 enter into this, but remember the vehicle with width 3 cannot enter into it, because even if it enters after the first section, it will not be able to go to the second section, right? Okay, so I hope the problem is clear, right? Now let us try to take some more examples and try to understand more about it by using pictorial representations, right? Fine. Now let us consider one more highway wherein we basically have a total length of 1, 2, 3, 4, 5, 6, 7, 8, right? And these are the width of service lane. This is the width of the service lane. 2, 3, 1, 2, 3, 2, 3, 3. So the same thing is being depicted here. This is the highway and this width 2 is represented out here. This is the width out here and this 3 represented here. This 1 is represented here, and then same way for each of this we have represented. Now when you say the entry is 0 and the exit is 3, what does it mean is, it basically means that you're going to enter from here and then you're going to come out after section 3. Now what type of vehicles can enter and exit? Remember, in this only a vehicle of width 1 can enter into it, because in between we have a section which is of width 1. In case if larger width vehicle enters, like for example 2, they will be able to complete the first 2 sections, but they'll not be able to enter in the third section, right? Okay, so from this, in case if it is entry is 0 and exit is 3, the largest width of the vehicle which can enter is 1, right? Let's take one more input out here. The width is same, only the entry point and exit point we are going to change here, right? Now if I say the entry is 4, you are going to enter from section 4 and you are going to come out from section 6, right? Now what is the minimum width of the vehicle which can enter here, it is 2. Vehicles of width 1 can also enter, vehicles of width 2 can also enter into this. Among those two, the largest vehicle which can enter and come out of this is of the width 2, right? Let's take some more example. If I say you need to enter from 6 and come out after 7, what is it? Yes, it is 3, because in both the sections the width is 3, right? Let's consider once more. You want to enter from 4 and then come out from 6, right? It is 2, because in between we have 2 here, and then 3 to 5, 3, come out from 5. What is it? 2, right? So we understood the problem. The next thing is, how do I put it into a program? Right? Now, the width of the service lane is given as an array here. Now they are specifying the entry point and the exit point, right? So, like for example, okay, now when they have mentioned 3 and 5, what is the job to be find out here? We need to find out the smallest element. Remember, here it is 2, here it is 3, and here it is 2 again. So, what is the smallest element in this section of the array? What is it? It's 2, right? Or if you take up the previous example here, you can just observe in this again, the smallest section is again 2, because this is 3, okay, right? Or 4 to 6, you can consider this way also. 4 to 6. In this, what is the smallest value? 2, which you can also understand from here. The smallest value is 2, right? Or here, from this index to this index, which is the smallest value? 3, right? I hope we are able to understand what we are supposed to do out here, right? Okay, in this section again, it is 2, okay? And here, if you can observe from here to here, the smallest section is 1. The smallest element here is 1, right? The problem is understood. What we need to do it is, first the input will be basically an array of all the widths, then there will be an entry point and there will be an exit point. We need to find out the smallest element, right? So we understood the problem and we also understood what we need to do the coding. Now let's move into the coding part. Let's begin the program. So first we'll be including a regular header file, because we generally use printf and scanf. Fine. Now first let us try to find out what is the total length of the highway, right? What we are considering out here, which is basically n. We'll try to enter the length of highway, right? Later on, when you place this in HackerRank, we need to comment this printf statements, right? And after that, we basically need an array to hold the width of each section of the service lane. In order to hold the width of each section of the highway, we are going to create an array of n elements, right? We'll ask the user enter the width of service lane, right? Clear? Right. So we'll scan one by one. So we require a for loop. Right. Now after reading this, we need to ask input like from which section you're going to enter and from which section you're going to come out, the entry point and the exit point. So we'll try to read the entry point and the exit point. We'll just try to request the user entry and exit. Fine. Now we need to find out, right? what we observed is our job was basically to find out the smallest element within this section from the given entry and exit, right? So let us try to write a function to find out that. Okay, so it's all about finding out the minimum element, right? Find min. Now finding out the smallest element in array was quite a common task. Like, assume that if you want to find min, right, what we used to do it is, we basically used to have an array, and then we used to have a number of elements, and then this is a general code. We just write the smallest element equal to the first element of the array. We used to consider the first element of the array, and then we used to run a for loop, and then anytime, okay, this could even start from 1, fine. If the present element a of I, if it is smaller than the present smallest, we used to update the small, and then we used to return the smallest element, right? This was the general code what we used to pass, wherein, okay, we should write for finding out the smallest element in an array. But here it's not about finding out the smallest element in an entire array, right? It's not about finding out the smallest element in an entire array. It's about from the given entry point to the exit point. So what I'll be doing it is, I will be passing not the entire array as well as, okay, the total number of elements in that. Along with the array, I'll be passing the entry point and the exit point. I'll be passing the entry point and exit point. Remember, this will be a starting index and this will be the last index, but last index is also inclusive, right? This is my exit point. Yeah, exit being a function, inbuilt function name, I'll try to use it as exit point, right? And probably entry point. Right, we need to declare these two variables here. Fine. Okay, now we are passing two arguments. We can just consider the starting point and the end point, right? This is my entry point, and this is my exit point. Fine. Now here I should not consider the first element, I should consider the entry point, right? Okay, I should consider the, which is basically from the section which you are going to start, and then this should not start from again 0, we should start from entry point, or entry point plus 1 is also fine because entry point is already considered here. And then again we don't have n, we have exit point. And since exit point is inclusive, you can do two things. Either you can write less than or equal to here, or what you could pass it, we can actually pass on exit point plus 1, so that I can keep this as common, I less than exit point, and everything else remains the same. Everything else remains the same. So let us try to write. I'll just collect return value. This is your minimum element, right? Okay, I'd like to print this. Largest vehicle which can pass through is, I'll preferably write it in a separate line here, so that later on if I had to comment it, it will be easier for me to comment this particular print statement. So I'm just trying to print this. Fine. So let's save this, right? Okay, now let me just go to the terminal and let me try to compile this, right? Okay, fine, no problem. If you want, we can look back at the input what is being specified here and try to rework on the, okay, work on the same kind of input what we had considered. We had considered 2, 3, 1, 2, 3, 2, 3 and 3, right? And then we had something like 0, 3, 4, 6, then 6, 7 and 3, 5 and then 0, 7. Let's try to do this here. So I'd like to run this here. Length of the highway 8. width of the service lanes. This is the width of the service lanes what we need to enter one by one, right? So here the width of service lane is 2, 3, 1, 2, 3, 2, 3 and 3. This is the width. Now if you want to specify, you can specify one of it, because we are not considered taking all the queries at once. We are only considered taking one query at a time. You can enter one of it. Like for example, if I pass on 0 and 3, then okay, the value should be 1. Between 0 and 3, the smallest element is 1, right? I hope it is clear. Largest vehicle which can pass through is 1. But for the same thing, if I just rerun the code and say the length is 8, and then this is the same input 2, 3, 1, 2, 3, 2, 3 and 3, right? If you would like to give something else like 4 and 6, right? If you enter from 4 and then exit from 6, then it is 2 being the largest vehicle which can enter as well as the exit. Fine. Yeah, if you want to do it on par with this, only thing is we are not taking only one query here. We are going to take number of queries also what we are going to enter, and then we will try to code it accordingly. Fine, let me just go here. So here, after reading the width, okay, first here this section, you are not only reading the length of the highway as well as number of queries. So if you want, you can read the number of queries here, right? Fine. And this this section we have to repeat for, okay, you can just say I equal to 0, I less than q, I plus plus for the number of queries. Every time we need to enter the entry point as well as the exit point, and then it's going to give me the corresponding output, which is matching exactly with whatever HackerRank wants, right? Done. Okay, let's go back to this terminal. Now we'll try to recompile this code. Okay, there is problem like I is not declared here. Let me just declare this here. Fine. Okay. So let me try to compile this. Compiled. Execute. First, length is 8, and after that you also mention the queries. How many queries you want? As per the input there, it was 5 queries, right? In the HackerRank problem, we'll try to enter the same. You can, if you want, you can just have a look here, like this input, right? This one we need to enter this. Okay, fine. So we are entering this 8 and then 5, right? Now we are going to enter the width 2, 3, 1, 2, 3, 2, 3 and 3, right? Now multiple times, like 5 queries we can pass on. 0 and 3. If you enter 0 and 3, what is this expected output? Here we have the expected output. Let us see how code matches, right? Yes, between 0 to 3, the largest vehicle which can pass is 1. Now let's again give 4 and 6. The largest vehicle we can pass is 2. Then again we'll try to pass on 6 and 7, right? Between 6 and 7, the largest vehicle can pass is 3. Fine. Now again, let us say if you say 3 and 5, the largest vehicle we can pass is 2. And then if I say 0 and 7, right, the largest vehicle can pass is 1. So my code is matching perfectly fine. Now again, if you want to take this and put it into HackerRank and then submit it, only thing is you can take the code, sorry, not required, okay, this code you can take it, I don't require this code blocks. Okay. You can take this particular code, put it into HackerRank, make sure that you disable this. I'll try to disable it here itself, right, and then put it out there. 1, 2, 3 and even this one. Fine. So that's it, is a task. Take this, go down here, we'll try to submit the code. Let us try to select the C language. Don't worry about whatever the existing code mentioned there. You can paste on your code and let us try to run our code here. Fine. Done. Submit it. Done, guys. All the test cases passed. Fine. Everything seems fine. Any complications here? No complications. Now, I'd like to redo this problem in a little bit different way. The problem statement remains the same, the input remains the same, the output remains the same. I'd like to do it in a little bit different way. Here, instead of passing the array and the entry point, which is an integer variable, and the exit point is an again integer variable, I'd like to pass the starting address and the end address. Like for example, if you pass the entry point as 0, I'd like to pass the starting address of an array, and then if the entry point is 3, then I would like to pass the address of the fourth one, the end address. From which address to which address you need to work on. Like for example, if the array is from, let us consider this array of 5 elements, like 1, 2, 3, 4, 5. Now let us consider the addresses 100, 200, 104, 108, 112, 116. So the elements what we had, and then these are the addresses. You can just consider these as the elements. What are the elements you consider? Now if I say you want to enter from here, you want to come out from here, I was actually passing the entire array and I was passing the index 0 and 2. Instead of doing that, I'd like to pass the starting address, and you want to come out from this section. I will not pass this address, I will be passing this address. Starting address, from where you want to come out. You want to enter from here, and then from here slowly you would like to come out after this. So I'd like to pass this address. Right? In order to do that, what I'd like to do it is, I'll be passing width, which is basically my starting address, plus entry point. See, if entry point is 0, it will be same as the starting address. If entry point is 1, it will be like 104. If entry point is 3, I'll be passing 108. Now in order to pass the end address, I require the base address of an array plus exit point plus 1 here. Like for example, if you consider, I would like to pass entry point is 0 and then exit point is 2. The indexes, I think if you consider indexes will be much better. 0, 1, 2, 3, 4. If you want to come out of this section, right, I need to consider this section. I will be passing 112 because this is inclusive, right? So I'll be passing this address. So for that, width, which is the base address, plus the exit point is index 2, width plus 2, like 100 plus 2 gives me 108 plus 1, 112. So if I do these changes here, I need to do the corresponding changes in the receiving of the parameters. So I'll try to receive 2 pointers. This is my starting address, this is my entry address, and this is my exit address. They are not an array and the 2 index variables. They are basically entry address and the exit address. So once you get the entry address and exit address, here using this pointer, which is a pointer here, this itself is a pointer, I'd like to dereference the pointer and get the first element. And then when you have these 2 addresses, if you want, you can calculate the number of elements by just doing exit address, the end address minus the starting address. Or you could even just keep using these addresses to do a comparison. Like if you start from 100 and let us say you want to, the end address is 112, right? Then we'll check out if this pointer, the starting pointer or the entry pointer, it is less than the exit pointer, then fine, you access this and then you move forward. Again you check out is less than 112 or not. Again you move forward, and once the fourth instance, when you just come down here, you say okay fine, we have completed all the iterations, right? So this code will be changing a little bit. We're saying while your entry point, remember entry point is a address, as long as this is lesser than exit point, I need to repeat the loop. And after that, to access the element, I'll be writing value at entry pointer, because these are pointers. If it is lesser than the small element, right, instead of writing a of I, I'm directly writing value at entry point. And I was incrementing this I. Instead of incrementing this I, I'll be updating this. This part remains the same, very much same. Small equal to perfect. Okay. Now I was updating this I. So equivalent to that, what I should do it is I need to update the start pointer, which is the entry point. is a pointer. We are making the pointer point to the next element. Everything else remains the same. Everything else remains the same. Fine. Let me just remove this information. Let's try to understand, is this working fine or not. So let me try to compile this. Okay, compilation perfect. Run. And since I have commented this printfs, so there is no print messages. So 8 and 5. Then I need to enter like 2, 3, 1, 2, 2, 3, 2 and 3. Right? After that, since I have given input which is similar to the previous input, you can just see 0 and 3 was the input, 1 was the output. And then 4 and 6 was the input and 2 will be the output. 6 and 7 will be the input and then 3 will be 6 and 7. 6 and 7 should have been 3 here. 1, 2, 3. Okay. Oh, there is a problem in the input. 1, 2, 3, 4, 5, 6, 7, 8. Right. So here in the input I have given a small mistake. 2, 3, 1, 2. Then 3, 2, 3, 3. I have entered 2, 3, 2, 3. So considering this one, 6 and 7, the output is 2. Fine. Clear? And then you can just mention, verify this and then, okay, 1 and 4. Perfect. Right. Now you might be thinking that what was the reason for actually writing this code? Okay, if you still have to verify this and then going to the HackerRank and then submitting this code, remember with the pointer 1, you can run this code and you can observe that this we are working with the pointer 1, it works fine. And you can also submit it, that's not a problem. Right? With the pointer 1 also, the code worked perfectly fine. Now, you might be thinking that why did I use a pointer when the simple one with the index variables, a simple array was working fine? The reason why I did this was because in order to do something very similar to this, exactly very similar to this, in C++ there is a built-in function. In C++ there is a built-in function, right? And the function name is called as min_element. The function name is called as min_element. Min_element, right? Wherein we pass something very similar to this. But that returns the address of the smallest element. If you want, you can receive a pointer and then dereference a pointer here, or you can directly apply the dereferencing operator. Remember, since this returns the address, I'm just trying to apply the dereferencing operator on the returned value. Or if you want to make it simpler, I would just write pointer minimum, right? And then this is my pointer declaration, and then I'd like to again dereference the pointer variable. Fine. Yeah, this one is present in algorithms header file, like I said, stl1 hash include. We don't require IOStream because I'm not using any printfs here, and this belongs from a standard one, standard namespace. Fine. Perfect. But remember, it's a C++, so you have to compile using C++, not using C. So I'd like to compile this code using C++. I'll write G++ servicelane.c. People working on other IDEs, make sure that you change the extension .cpp. C, because algorithm does not work on C. So make sure that you select C++. Right? It can be C++ 14 or C++ 11, that doesn't matter. Let's try to run this. And yeah, I would like to even remove this code and show you that, okay, this code has nothing to do with that, because we're not using this code. Right? So let me try to remove this, because the code which are not using it, why should I unnecessarily retain that? Fine. Okay, I'm not using this user defined function, I'm just using the built-in function. Right? Remember, if you want, you can also use a vector here, but those algorithms works on primitive arrays also. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . I hope the concepts are clear. Right, all test cases passed here. So let's have a look at the code, final code here once more. Right, this is not required, so I'm just removing this, and I'm actually removing this code so that you can see more code in the screen here. Any of these are comments, not required. Right, we're not using the user defined function, using a built-in one, and this is also not required. Right, okay, that's the code. So you read the entry point, exit point, call the minimum element, which is a built-in one, you pass on this, that's it. Right, but please do remember it's a C++ program, not a C program. If you want, you can replace the scanf with C in, right? If you can want, you can replace this with vectors. Fine, this can be done. Thank you guys.